Okay, so we're going to keep talking about probability today. We're going to cover two different sections, but honestly, I'm not even necessarily, I'll try to remember. I won't necessarily tell you where one section starts and stops because these are both very, very, very similar topics. So let's just say we're going to look at sections 6.3 and 6.4. Okay, so this is kind of real life probability. So real life examples where we might use probability in order to determine predictions on things. Okay, so one purpose of studying probability is to predict future events. And not just based on vibes, we're going to try to predict future events based on facts, based on math. So while it might not always be the most accurate to look at the past to try to figure out what we expect in the future, it's better than going on vibes, okay? And so a lot of times that's going to give us, I would call it a very educated guess on what we expect to happen in the future. Okay. So I'm putting a star by this. This is a term I'm going to want you to know, okay? But expected value is a form of weighted average. Remember, that was a question on your exam. I think it was the bonus question, but it asked you when would you use weighted average, okay? Or when would it be appropriate to use weighted average rather than regular average? And so it is, remember, used when the values are not equally weighted. Okay, when you figure out your grade in this class, you have to use a weighted average, right? Because different assignments are worth different percentages of your grade, okay? Tests, of course, being the most common. So here's the formula for expected value. We're actually going to shorten it and call it E of X, okay? Don't let that throw you off. That just means expected value. So I'm going to give you the formula in everyday language. The book is going to give you the formula in very mathy language, okay? And I don't always think that's necessarily helpful, okay? But here's how you're going to find expected value. You're going to take value number 1, and you're going to multiply that times the probability of value number 1, okay? And then you're going to add value number 2 times its probability. And you're going to go all the way through the list of values until you run out of numbers, okay? So I'm just going to say plus ... here, and that actually needs to be there because that implies you need to keep going until you run out of values to work with, okay? Okay, so let's look at some expected value questions where this might be a formula that we would use, okay? So again, we're going to look at real life probability today. So times when you actually might be able to use probability to make good predictions, okay? So we are going to be talking about a little bit about death today. Okay, that is not because I'm morbid or I really want to talk about that topic. It's because we have a lot of data based on when people are born and when people die. Okay, the state, the federal government actually keeps record of that. So a lot of times we have like death rates and stuff like that. Okay, so let's talk about life insurance. A lot of you probably haven't ever thought of that because you're pretty young. Okay, but life insurance pays your family when what happens to you?
When you die.
When you die. Okay, if you do not die, you do not use that insurance, okay? In other words, you don't get money, okay? It's kind of like car insurance. When do you get paid, quote, for your car insurance?
When it crashes.
Yeah, when you have an accident, right? You don't get paid on your car insurance if you're a safe driver and you've never had any accidents, right? It's only there for emergency situations, and that's what life insurance is too, okay? Okay, so let's say that the policy costs $200 a year. By the way, that is a real cheap policy, so life insurance is going to be a little bit more than that usually. But let's say in 1 year, it is estimated that 10 people of the 1,000 people that have policies, pass away. And if they pass away, they receive $100,000. Well, technically they don't receive it because they're what?
Dead.
They're dead, yep. But their family receives it, okay? And then so the question is, what is the expected earnings per customer? So this word expected is key, okay? When you see the word expected in a formula on your homework, you need to expect that you're going to use that expected value formula. What is the expected earnings per customer? So I'm going to give you a minute to write that out, okay? But if you're kind of a little slower or you just came in late, you might want to just take a quick picture of that, and then you could fill in the gaps later on. So we're going to come up with a little table, okay? So I'm going to kind of title this table Earning Possibilities for this life insurance example. Okay, there's only two possibilities as far as whether you will use this life insurance policy or not, okay? You will either live over the course of that year if you have a policy, or unfortunately what? You will die, okay? Okay, so let's talk about the people who live. Like, good job they live, right? But they don't get any money, okay? So if they don't get any money, they're going to have to pay the $200 a year without getting anything in return, okay? So what have they earned if they're paying $200? They don't get $200, they lost $200. So how do we say you lost $200?
Negative 200?
Yeah, we're going to call that negative, okay? I still think they're probably pretty happy about that. Why, though?
They're alive.
They're alive, yeah. So, $200, who cares, right? You're still alive, okay? What about these people? At least their families are going to get what for a payout? $100,000, right? But they're also still going to have to pay their policy premium, right? Like they still have to pay for the product, okay? So they're actually going to get, I'm going to put it in parentheses, they're going to get their $100,000. But they're going to need to take off $200 because they had to pay for that policy, okay? So you can use your calculator, but that would actually be what? Somebody do the math for me. I think it's $99,800. Okay. Okay, so this table is just kind of organizational. Okay, that's the only two options, right? Can we all agree you either live in this example or you don't live, right? That's the only two options. There's not a midway, okay? So your expected earnings, which is what the problem asked for, okay? So this is going to be a weighted average. Your expected earnings, okay, are going to be, the first earning is negative $200. And so we're going to need a probability here, okay? This is going to be the probability of the first event, okay? So the probability of living goes here. And then we're going to add that to the 99,800 quantity. And then what are we going to put in parentheses and words here? This was the probability of living, so this will be the probability of what?
Dying.
Of dying. Okay.
Don't they have actuaries to figure that out?
They definitely have actuaries to figure that out, okay? That is why an older person has to pay a lot more for life insurance than a younger person does, right? Because what's an older person more likely to do, unfortunately? They're more likely to die, right? So a younger person doesn't have to pay quite as much. That's the reason, by the way, if you've ever wondered, like, why do I have to pay so much for car insurance, okay? Why do you have to pay, as a young person, so much for car insurance? Because people in your age group, maybe not you, but other people in your age group happen to do what pretty often, more so than older people? crash, right? So that's why you have to pay more as a younger person than an older person does, okay? All right, so let's talk about the probability of dying. So we've got some numbers here. We've got 10 out of 1,000 people that are going to unfortunately die, okay? So we're going to put that here. So 10 out of 1,000 goes here, okay? So I'm going to put a multiplication dot there just to drive home that that's what we're doing. What about the probability of living? I didn't mention it, but if 10 people don't make it, how could we figure out how many people do make it? Subtract, right? So the people who will live, we could just do 1,000 minus 10, right? And that would mean 990 of those people that we talked about are going to make it, right? So we're going to list 990 out of 1,000 for the probability of living. So this is where I want you to have a calculator. So let's go ahead and punch that in. I'll try to see if I can get it visible on my screen here. But I want you entering this in with me because on your own, you're going to have to enter in kind of weird numbers like this. Some of them might be decimals. Some of them might be fractions, okay? But negative 200 times, let's just do a parentheses, 990 over 1,000. So 990 divided by 1,000. And then plus 99,800 times 10 over 1,000. Okay. So let me scoot this, see if you can see a little bit more, but it kind of scrolled over a little bit. Okay, so the fact that we got $800 means that that amount is positive, okay? So this is the expected earnings, so we need to list this as money. So by the way, this probably wouldn't be a very realistic set of numbers because the company's actually not making any money as an average, okay? So in real life, this would probably be a negative number, right? Meaning that on average, the customers actually lose money because most of them are just going to pay for their policy and not actually gain anything from that.
So can you repeat that? $800 is how much the company will make?
No, this is the expected earnings per customer. Okay, so that's why I'm saying it's not a very realistic thing, because that actually means that the company is not doing appropriate math for their business because they're actually paying out on average $800 per person. So that would be a bad business plan. Okay, so probably, to be honest with you, that would just mean that this insurance needed to cost more. Okay, so with this kind of coverage, the insurance would need to cost more if the company was actually going to make money. Okay. So you can use a table with any of the problems on the homework if you feel like there is a lot of information that you want to kind of keep straight, okay? So that can be one way that you can make sure that you keep it straight, okay? Okay, so let's do another one kind of like that, okay? So the state fair just kind of wrapped up. I think it's over, isn't it? Did anybody go?
Yes.
Yeah.
You did? Was it major expensive? Everybody kept complaining about that.
Yes.
Really expensive? Yeah, that's what I heard. I haven't been in like 10 years. Okay, so let's suppose that at the state fair there was a raffle, okay? Do you know what a raffle is? You pay to play and then you can win prizes if they draw your name, okay? So some people do them on like social media too. Okay, so let's talk about what prizes you can win in this fake raffle that I'm making up. 1 in 5 win a free ticket, meaning a free raffle ticket, okay? So that is only worth $1. I mean, you'd be happy about it, right? But that's not an amazing prize, okay? 1 in 100 are going to win $5. 1 in 100,000 are going to win $1,000. And then finally, 1 in 10 million will win $1 million. By the way, this is a really simplified kind of version of our lottery. Are you likely to win the lottery if you pay any attention? Are you likely or unlikely to win the lottery? Pretty unlikely to win the lottery, right? Like, I don't think I know anyone who's won the lottery, right? So, pretty unlikely. So again, go ahead and catch up with that if you need to, but I want you to write down that problem. And then notice I use this word again. Okay, make sure that you get that everyone actually has to pay to play this game. So everyone pays how much to play? How much per ticket? $1. So you're actually going to need to subtract $1 off of any winnings that you see. Okay, so subtract that off of the expected win. Okay, so I want you to think about this, but let's talk about the different options that you could win. Okay, and we're going to go through them in order. Okay, not necessarily the 1 in 5 part, but I want to talk about what the prize is, right? The first person gets a free ticket. So what do they actually win? Think that through. They actually don't win $1 though, because they still have to use that ticket to play. Does that make sense? Okay, so actually they just don't lose any money, which means what do they actually make?
0.
They actually make 0. Okay. And then if you win $5, right, you won $5, it's cool, right? But how much did you actually win since you still had to pay $1 to win that $5?
$4.
$4. Okay. And then what about here? You win $1,000, but you still got to buy that ticket. So how much are you actually winning? $9.99. I'm still happy about that if I'm you. And then last but not least, we have $1,000,000 minus 1, okay? So let's talk about that. So do that on your calculator, 1 with 6 zeros and then minus 1, okay? That is $999,999. I'm actually not going to do a comma there because I've already used commas for all of these. Now, if you don't love that, you also could just subtract $1 at the end of it, okay? Or, by the way, you could lose $1. So if you lose $1, it's -1. Okay, so the expected win. Again, because we see this word expected, we're going to use the expected value formula, okay? So let's talk about the winners first, and then we'll end with the non-winners. I didn't want to say losers because that sounds mean. Okay, so we've got $0, and 1 out of 5 of people are going to win $0. The next win is $4. Read that, right? How many won 5? But we already talked about that it's only actually $4. 1 in 100. The next win is $999. Okay, read that. How many win that? 1 in 100,000. So make sure your number of zeros is right. And then last but not least, we have the big prize, right? $999,999. And that's 1 out of 10 million. So that is 7 zeros. 1, 2, 3, 4, 5, 6, 7. But then probably the most important thing to do here is most people are actually going to win -$1. So we have a final entry, and it's really important that you include it, or your answer is going to be way, 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 way off. okay? So how are we going to get here? We need the probability that we don't win the game. Okay, so how could we get that? We're just going to use our calculator to do it because, listen, it's pretty ugly. Okay, how could we find the probability that we don't win? Here's all the times that we do win something, right? How could we find the probability that we don't win? We could just add these probabilities and take them away from 1, right? 1.0, or if we're doing percentages, it would be from 100%, okay? So to find the probability that we don't win, this is how we're going to do it. We're going to do 1 minus 1/5 plus 1/100th plus 1 over 100,000. Make sure you have the right number of zeros because, listen, and that's going to be the hardest part. And then 1 over 10 million. So 1, 2, 3, 4, 5, 6, 7. So I'm going to do that on my calculator. So 1 minus 1 out of 5 plus 1 out of 100 plus 1 out of 100,000. That is 5 zeros. One more. And then 1 out of 10 million, and that is a 1 with 7 zeros after it. So I end up getting this decimal, 0.7899899. So I'm going to make this a little bit bigger so I have more room. And I'm just going to tell you this, we don't need to round this number. I know it's a weird decimal, okay, but that's because we were adding all sorts of fractions to kind of get us there. Okay, so I already entered this in, but I just want to kind of show you on screen what that's going to look like. So we're just going to enter in the whole list. 0 times 1/5 plus 4 times 1/100th plus 999 times 1/100,000. And then plus 6 nines. Sometimes it's easier for me to count like that. Times 1 over 10 million. And then don't forget the negative 1, plus negative 1 times parentheses 0.7899899. So if you're not doing this along with me, just maybe try to do it at home. Like, don't just take my answer. Make sure you could punch this long list into your calculator and get the same thing that I'm about to enter, okay, or about to get. So why isn't it surprising that we got a negative number? Right, because of the negative 1, because we had to pay to play this, right? So that means that we're not going to be expected to be winners for the most part, okay? So the average win per person is that actually we lose 64 cents on average per person, okay? But realistically, what is most people going to lose in this game? $1, right? It's not a crazy amount that you're going to lose, right? So if I were playing this game, I would probably think it's worth the risk, right? Like, who cares? It's $1, and I might just win, you know, $1 million, okay? But that's how they get you, right? So, all right, so I just want to talk about that. So this is the expected value, but just know that that's a little misleading. Because if you actually wanted to know what you can expect to lose on this game, it's probably going to be more like the mode of the problem, which would be negative $1. So the mode option is that you will lose $1. Okay, so I don't know if you remember, but when we talked about mean, median, and mode, I said sometimes mean, even weighted mean, like we're doing right now, weighted average, is not going to be the best predictor, actually. The mode would be the best predictor of what you can expect in this game. Okay. Okay, So we're going to do one more with percentages, just to make sure we have it down. But anytime you see the word expected, then you need to know that you're going to use this expected value formula, which is value times probability plus next value times next probability plus all the way through the list until you get to the end. Okay? And negative numbers are possible, especially when you're expecting to lose something. Okay? Okay. So let's do one last example. I would say this is probably the least, understandable example, because most of us probably aren't going to be bidding on artwork anytime soon, but I wanted to do one with percentages, and this is a good example of that. Okay. So let's say you're bidding at an art auction, which I've always wanted to do that, except I don't want to use my own money, so here we are. Have y'all seen that in movies where they accidentally bid on something that's $100,000 and they're like, oh my gosh, what do I do? Okay, so let's say you're bidding at an art auction and you're trying to decide whether or not to bid. Let's just say you have grandma died and left you an inheritance kind of money, okay? Whether or not you want to bid $50,000 on a painting. Okay, but let's say you're a business person, okay? The reason you're bidding that much is because you think you can resell it, okay? So let's say that you believe you have a 60% chance to sell the painting to someone else for $70,000. And you have a 10% chance to sell the painting for $100,000. So to hit a home run. And then let's just say if you can't make money, you're just going to keep it. Okay, so otherwise you keep it and maybe you save it for a time when you think you can make more money. So otherwise you keep the painting. What is your expected value of that bid? So I apologize, word problems are kind of wordy, so I'm going to pause, let you write that out. And again, I'm going to underline this baby because when you see expected value, we're using that formula. So I'm going to box in your three options. You're going to spend 50, so maybe I'll underline our three options, okay? So you might sell it for 70, you might sell it for 100,000, or you might keep it, okay? Does everybody agree that's the three options that I gave you, right? That's the only three that I gave you, okay? You're either going to sell it for 70,000, sell it for 100,000, or you're just going to keep it altogether. Okay, so again, make sure you understand what it is that you're doing, right? So we're going to talk about the expected profit, okay? Make sure you know what profit is, right? That's the extra money you get. That's not the money that you sell the painting for because you still had to buy it for 50 grand, okay? Okay, so let's talk it through. How much are you making in profit if you sell it for 70,000?
20,000.
20,000, right? I'd be happy with that, okay? You're making a profit of 20,000, okay? And the probability is 60%, so how do I write 60% as a decimal? Move the decimal back twice, right? So that would be 0.60 or 0.6, okay? You need to make sure you can move your decimal forward and backwards twice when you're talking about percentages and decimals. Okay, Okay, so let's move on to this second option. Okay, how much profit do you make if it's 100,000? You spent 50, you made 100, which means you profited how much? 50, good. If you can't do that in your head, you're just going to need to subtract on your calculator. Okay, what's the percentage chance that you're going to earn that 50,000 in profit? 10%, so what's that decimal? 0.10, okay? And then the other option is you keep it. How much do you lose if you keep it? Because you had to buy it still.
Negative 50.
Yeah, you actually lose negative 50,000. Okay, how am I going to decide what goes here?
We add the chances you could win and subtract that from 100.
Well, it's like this is 60%, right? This is 10%. Okay, so how could we figure out what percent this one would be? Yeah, those from 100, right? So what would be the chance that you would end up keeping the artwork? So this is 70% together. Taken away from 100 is how much? 30%. Okay, so this would be 30% because we subtract from 100. So that would be 0.3. Okay, so I want you to take like 30 seconds. I want you to actually punch that in your calculator, just like it says. I want you to do this times this, plus that times that, and then plus the negative number times the 0.3. So I'm going to label this probability of keeping it. That was what we wrote there. So we're going to talk about the answer once you get it, and then we're going to talk about real life too. Okay, because that is a lot of money put out for an art piece, so keep that in mind. Okay, so those of you who punched it in your calculator, did you get something positive or did you get something negative?
Positive.
It is something positive. It's on the smaller side, though, compared to 50,000, right? So what'd y'all get as far as your positive number? $2,000. Okay, so the math says that that's actually a good investment, by the way. Okay, because it's positive. What if it were negative? Then that would definitely be a what kind of investment? A bad investment. Okay, but can you think of a real life reason why you still might not want to do this? Like, you better have a lot of money, right? Like, that's a lot of money to risk. Okay, so this is an example of just because the numbers show something doesn't mean it's always practical that we do the thing that we're trying to decide on. Okay, so if you didn't have $50,000 you were willing to invest into an art piece that you might be keeping, then it doesn't really matter what this number is, to be honest with you. Okay, so in the real life setting, you might not want to do it just because of that reason. Okay. And so the last thing that I want to talk about in this unit, and then we're going to just continue on with the next section, which is a really, really common thing, is I want to make sure that you have seen before or you know how to cross multiply. Okay, so I'm going to give you an example of it. But you are going to need to know how to do some math in the next few problems that we're going to look at. Okay. So if I told you that it was 2 out of 100 on this side equals how many out of 7,980? And that this was your unknown, so we're going to call that x. Okay. The fact that this is unknown just means that this is what we want to know. Okay, so if you've seen cross multiplying before, what does it mean? It means you're going to do this times this, okay, and you're going to set it equal to that times that, okay? It's literally multiplying diagonally, okay? So let's talk it through. What is 100 times x?
100x.
100x, okay? And then 2 times 7,980. So if you have a calculator, do that for me real quick. What do y'all get when you do 2 times 7,980? I'm going to wait for y'all to punch it in for me. So what do you get? 15,960. Okay. And then how would I move forward with finding out what x is then? If I not subtract though, I would want to do the opposite of what's happening here, right? It's 100 times x, so I would want to divide. Okay. So you are going to have to know some arithmetic steps. Okay. This isn't really even algebra, despite the fact that there's an x. Okay. It's just really more arithmetic steps. And so in the end, you're going to divide. So if you take the 15,960 and you just divide that by 100, okay, you're going to get about 159.6. Unless you're told otherwise, I want you to include any decimals that are in your answer, okay, unless it just doesn't make sense for the problem. Okay, so let's talk about another kind of common gambling game. We talked about craps a little bit last class. So let's talk about roulette. I'm not suggesting that you go to a casino. It's actually not a great investment, okay? But I'm just saying there's a lot of probability we can talk about with things at a casino, okay? So don't go home and tell your mom that I'm telling you to gamble. I'm actually telling you not to gamble because all the gambling games are going to probably make you lose your money. So let's talk about roulette, okay? I actually hate roulette. I have some friends that love to play roulette, okay? But I hate that game. I always lose at roulette, okay? So 18 black numbers, 18 red numbers, and then there is a 0 and a double 0, and those are green. Okay? So have y'all ever at least seen a movie where someone's playing roulette? Do you know what the game I'm talking about? They put like a little marble and then they spin the wheel, right? And then it lands on a number, okay? You can bet on a color. You can say, I think a black number is going to come up next, okay? Or you can say, I think the number 12 is going to come up next, okay? There's all kinds of bets that you can make, okay? So let's use our knowledge from last time. So my first question is, what is the probability, I'm going to abbreviate probability like this, of a red spin on any spin? Okay, so you don't even need the skills from today to be able to do that. You need the skills from last class to do that, okay? All right, so let's talk about the total number of options. Okay, you have 18 black numbers, okay? How many red numbers? 18 reds, okay? And then you have these two different color spots, right? How many, that's 2 more, right? So for a total of 38 different options. So what should be the probability of red then? I'm going to do the easy part for you, and then you're going to tell me the other part, okay? 38 goes on bottom. Why? That's the total number, okay? And then I want the probability of red, so how many red numbers did I tell you there was? 18, okay? So we're going to use our calculator to reduce that. So 18 over 38. If you push enter and then you go to the math menu and then the first choice is fraction, okay, that's why I wanted you to have this calculator at home or at least the app. So that's going to give you a reduced fraction of 9 out of 19. So let me give you the decimal and then you're going to tell me what the, notice I rounded the decimal. So the 6 digit you see got rounded because the digit after it was an 8, okay? So what percentage would that be here? 47.37%. Yep. Okay. Okay. So let me ask you a second part, okay? By the way, I have a funny real story about roulette, okay? Last time we went to the casino, I already said I don't like roulette, but my husband's boss, who I am friends with also, he Venmo'd me $100, and he said, like, go to the roulette table, and I want you to put all of it on, I forget what he said, either black or red, okay? And so I was super nervous because it was like somebody else's money. It was $100, and I just didn't want to lose it because I'm like, if I'm going to make a bet, it's going to be like $1 or something. He wanted me to put a $100 bill on either red or black, okay? And so you basically have a 47.37% chance of winning, okay? And I actually landed on one of the green numbers, which is not likely at all. And I lost all his money in like 2 seconds, okay? Because I got the very thing that is actually pretty unlikely. Because how unlikely or how likely is it to get a green number? Not very likely. 2 out of 38, right? So a much smaller number. So I was like, sorry, bud. Like, I almost wanted to video it and say, like, I didn't just steal your money. But actually, the casinos don't allow videoing. So I couldn't do that even if I wanted to. Okay. So let's say that one day, this is probably a low estimate. Let's say the casino spins the little wheel that is the roulette wheel 100,000 times. That might be like a total for all the roulette tables. So my question is, how many are expected to be red? So there is multiple ways to do this, but the way that we're going to practice setting this up is going to be through setting up something where we can cross multiply like we did up here, because we're going to need that skill in the next section here in just a few minutes. Okay, so I'm still talking about red, okay? So my 9 out of 19 fraction that I got in part A still stands. Okay, so I'm going to write that down first. And then I don't know what goes on top, but I do know what goes on bottom, right? What's the total number of spins that I said that the casino did? 100,000. So one more zero. Okay, so if we don't know what something is, what do we call it? X. Okay, and then we're just going to do what? Just like we did above example 4. We're going to cross what? Cross multiply. So that's going to give me 19x equals 900,000. You're going to use your calculator for these larger numbers, so don't let those intimidate you. So then what would be the last step? And then I'll have something I can punch in my calculator. Divide by the 19, right? So if you divide by 19, okay, let's just look at what that is on your calculator, and then let's talk about what makes sense as far as an answer goes. So 900,000 divided by, let me see if I can get it visible there, divided by 19, okay? It's a decimal, okay? Would it make sense for that to be a decimal when I'm asking you how many spins are going to be red? Can you have a decimal spin? No, like it's not going to stop in the middle, right? They would actually like think something was wrong if that happened, okay? So we're just going to use that. Remember last class we talked about the little squiggly equals when we're rounding, okay? So we're just going to round it to the nearest whole number. So it's going to be 47,368 times, okay? So I'm going to label that as that many spins would be expected to be red. So you're going to use that cross multiplication trick whenever you have like 2 fractions set equal to each other. One on the left, one on the right. Okay, we're going to cross multiply in order to solve that. Okay, so before we move on to the next section, I do want to talk about this especially because I don't want you to think Miss Newton is like a gambling fanatic. I'm really actually not. But there is something in this section called the gambler's fallacy, and it doesn't always have to do with gambling. Okay, it has to do with predictions more than it always does with gambling. And that is just the mistaken belief So it's not true that a streak of bad luck means that good luck is coming. So I'm going to say makes a person due for a streak of good luck. And listen, I'm not trying to rain on your parade. It's just that's not the way it goes, okay? And again, this does not have to apply to gamblers, okay? This also applies to what I mentioned the last class, right? What is your chance of getting a girl or a boy baby every time you conceive a child? 50-50, right? Because it's a mistaken belief to think that, oh, I've had 5 boys, the next one's definitely bound to be a girl, okay? Mm-hmm. So that's gambler's fallacy, right? That's not saying that that's what's going to happen, right? Because your next kid will be a girl or a boy with the same percentage, right? With what percentage to what percentage? Still 50-50, okay? So gambler's fallacy is thinking things are going to change necessarily, okay? And that's not a negative comment. It's just, it's not mathematical. It's not legitimate, okay? Gambler's fallacy, again, does not have to do with necessarily gambling all the time, okay? But it would have been a mistake for me to take my boss's $100 and be like, hey, I just lost with his $100, so now I'm going to play with my $100 because I'm definitely going to win because I just lost, right? I probably would have done what with my $100 if I would have done that?
Not spending it all?
I would not have made a $100 bet because I would have been too nervous to do that with my own money. But I probably would have lost that money too, right? So it doesn't mean anything, right? The ball on the little wheel didn't know that I just lost my boss's $100. Okay, so I wouldn't have been smart to bet my own money, and I didn't. So no worries. I'm pretty sure I still lost some money that day, but it was not at roulette. Okay. Okay. So we're just going to go straight into section 6.4. Because section 6.4 talks a lot about bigger numbers in our probability questions, okay? Section 6.4, let me see what it's actually called. It's actually called something about life expectancy, so I'm going to give you a title. Yeah, ideas of risk and life expectancy. So I'm just going to take out the word ideas, but this is risk and life expectancy. Okay, so there are some terms that you might not have heard before in this section. So I want to just quickly define those for you because there's actually a couple homework questions where you'll have to do something with these words, okay? Vital statistics. So if you're a nurse and you take somebody's vitals, what does that mean? If you're a nurse and you're taking their vitals, it usually means you're like taking their important measurements, like maybe heart rate or their temperature or something like that, okay? So vital statistics are any data concerning life or death, or actually concerning births or death. So how many babies are born and how many people are dying. So I don't know, maybe it's called vital statistics because it's like important or something, okay? Okay, have you ever heard of the term life expectancy? So if your life expectancy is long, what does that probably mean for you? You're going to have many more years on this earth, right? If your life expectancy is not very long, what does that unfortunately mean? You don't have very many more years to live, okay? So life expectancy, just specifically, is actually the number of additional years that you can expect. Okay. Now, of course, there's always unexpected deaths, so that's not really what I'm talking about. Okay. So which age group of people would have the biggest, largest life expectancy?
Young people?
Very young people, babies specifically, right? They would have the longest life expectancy. Okay, who would have the smallest or shortest life expectancy? The older people, right? Okay. Okay. So let's do just a couple examples. So I'm going to call that example 1 since it's section 6.4. Okay. So this is real numbers from 2020. So let's say there are 330 million people. Okay, I think that's people in the U.S. And let's say that in 2020, there are 173,000 deaths from accidents. And 599,600 deaths from cancer. So let's find the death rate for accidents and cancer separately. So I don't mean those together, per person. I think we're going to do this example and then one more, and then we'll see where we're at for time. Okay, so let's kind of box in the important numbers. This number is going to be important because that's the total, okay? And then we've got this number of people from accidents that were dying, right? And then we've got this number of people from cancer. So I did like a single underline for accidents, double underline for cancer, just to kind of keep it straight. Okay, so let's look at the accident rate first. Okay, so how could I figure out a fraction or a probability quote for an accidental death?
Put the number of deaths of accidents on top of the total number of the population.
Right, so accident number goes here, and what always goes on the bottom of a probability fraction? The whole, the total. Okay, you can put the commas if you want. Usually you don't see commas in the form of a fraction. Okay, so I'm going to punch that in my calculator, and listen, you're going to need a calculator for your homework this time. Like, there's no way around it. Okay, but I wanted to talk about what you do when the calculator gives you something weird like this. Okay, because this actually has a meaning. So this works out to be about, I want you to write down the number, and then we're going to talk about what it means. Okay, so on the calculator, it's actually 5.2424, and then it has this E thing, and then a -4. Okay, this is what you get on the calculator, and I want you to know how to read that. So this means move the decimal place back 4 times. Okay, so you are going to have to be able to do that on your own. Okay, so in other words, let's do just that. So 5.2424. I'm going to move the decimal place back 4. So it's 1, 2, 3, 4. My decimal point's going to be there. Okay, what am I going to put in all the spaces that you see? zeros in all the spaces, okay? So the reason it is a tiny decimal is because it's not very likely that you die from an accident, okay? So the decimal would be 0.00052424. Okay, so the calculators are really good at doing a lot of things. I don't necessarily love the way that they show really small decimals like this, so you're going to have to know that when you see this, so let me show you again. When you see this, it just means move the decimal place back however many times it says there, okay? So it actually means exponent or times 10 to the negative 4 power. Do y'all remember in junior high looking at science questions where it was like scientific notation? That's the calculator's shorthand for scientific notation, okay? All right, so let's talk about cancer rate. And then let's make sure we can read the calculator from that too. So what was the number of cancer deaths? 599,600. It's still out of how many total people? 330 million. So let's see what that one comes out to be. So 599,600 divided by 330, and then a million, right? Yep. 7 zeros. Okay. Notice this one, it actually is okay with the decimal as is, so you don't have to do the decimal moving for this one. So it's a little bit nicer. It's because it's just a little bit bigger. So it's 0.001817. Okay. I really am going to want you to probably have at least 4 digits other than the zeros. Does that make sense? Okay, so it means you're going to have to, on these really small, tiny decimals, you're going to have to include more decimal spaces. Okay. So the only reason I included 5 on this first one is just honestly because it had a pattern where it was like 2424 forever, and I just wanted to list 2 of the 24 patterns. Okay, so let's do one more. Let's end it on a positive note. Let's talk about births instead of deaths, because we talked enough about deaths, I think, okay? All right, so let's say that in 2020, the population was 329,521,477 people. And that year, there were 3,605,201 births recorded. Okay, so don't get thrown off by the fact that these are really big numbers. Okay, real data is usually pretty big. Okay, pretty ugly. It's not going to be super, super nice. Okay, so I want you to find the birth rate, but instead of just the birth rate, I want you to find the birth rate per 1,000 people. Okay, meaning how many babies were born per 1,000 people. That's what I mean. Okay.
Request one? I don't mean. Request one? I don't mean.
Yeah, and we will. But we got to set it up first, okay? So first off, we need to come up with our original fraction, right? We had this many births out of how many? That many people, okay? We don't want to say that number, right? So I'm okay with you just saying that, right? But that's 3,605,201 births for every 329,521,477 people, okay? And I want to find out how many per 1,000 would there be, okay? So what am I going to put in place of that question mark? An X. Okay, and then I'm going to do what? That I've already done twice today. I'm going to cross multiply, and I'm going to use my calculator because listen, these numbers are real ugly. Okay, so I'm going to get this 329,521,477 number, And then if you do 1,000 times this number, you're going to get the same number and then just add 3 zeros. Okay? So these numbers are big, right? But how did we do the easier, smaller values? How do you get x? We're one step away from having the answer. How would you get x by itself? Just the same way that you did before. Just divide. Yes, it's a big number, but make sure you write it down right and do the same thing to both sides.